we will be working with Node and JavaScript. It doesn't require a lot of JavaScript knowledge to understand this. If you don't know anything about JavaScript, don't worry. It's pretty readable if you know anything else. And it's more about the concept of using OpenAPI to develop a REST API. So any other questions before we get started?
Nope, thank you.
Okay, cool. So like I said, today we're going to talk about REST APIs and the technology OpenAPI. So before we dive into that, I do need to go ahead and do my shameless self-promotion and talk a little bit about where I work and what we do. So I work for a company called Pros. We're based here in Houston. We actually just opened a brand new headquarters on Kirby right next to House of Pies. It's a giant building, brand new building there we're super excited about. We've been here for 30 years. You'll see a little bit of that in this video I'm about to play. But what we do is we use machine learning and artificial intelligence to solve a variety of different business problems, mostly surrounded around pricing, but there's a lot that goes into pricing. So you'll hear them talk in this video about, working with the travel industry and airlines, and that's where we got our start. But we also reach out into what's called the B2B market, or business to business. So for example, if you have let's say you're a restaurant supply store, okay, and you sell ovens and tables and everything you need to set up a restaurant. So if you have, you don't set a price, you need to set prices on those, but maybe you package them all together in one big quote. So if I buy more stuff from you, it'll be cheaper. Well, now we can't just have an individual price. We need like a quoting tool that says, okay, all of these things together, how much do they cost? What kind of discounts can we throw on there? And we provide stuff like that that's backed by an AI, or real-time pricing, where if you have, an asset that its price changes dynamically, like an airline ticket, you can have your sales automatically updating prices. So that's what we do. And here's a little bit about us and the history. If you can't hear this video when it plays, let me know, and I'll see if I can fix that.
We're unable to hear it, Chris.
All right. Let me double check this. All right, let's try this again. All right.
Culture's special and the people are special. And the relationships we have with our customers are special. What we did was to start with an airline called Southwest Airlines. They had a severe overbooking problem because they ran high load factors. Those load factors gave us the ability to walk in with an idea for them that said, look, if you'll give us your data, we will come back and give you a solution to your biggest problem, which we think is going to be flight overbooking.
We all knew that what we were doing had tremendous value to what we offered to our airline customers back then, and it was not smooth sailing. It was not easy. It was actually a lot of work.
We didn't have a big development department, so when we came up with something initially, it would just be Benson and I taking an idea that Ron may have come up with, and then start bouncing it back and forth between each other, and then turning it into algorithms.
Be brave, have the courage to come up with ideas, have the courage to do whatever you think is necessary to have a customer succeed.
And I remember talking about the risk that we would be taking, because it was a young fledgling company, and but I think we all felt that this is going to be something truly big.
I negotiated the contracts, and we argued about the price, but I just told them this is what it's going to be, and they signed it. So he said, I can't believe that you did this. You've got brass balls. And I'm like, oh my God, that's a compliment if I ever had one. We started off kind of as a family, and it just kind of went from there. And I think the early employees had that attitude of, you know, we're not going to let anybody down, and it just kind of continued going that way.
It's not one person, it's the company, and without the support of everyone, and everyone actually coming together as a team, none of us would be successful. So together we succeed. It's the culture.
We had a users conference. When Lufthansa started their presentation, they started with a big picture, and it was their new headquarters building. And they started around the theme that this is the building that pros built. And I almost cried. I mean, it was just like so powerful. When you look out and you see 1,000 employees plus, and you realize there's 1,000 families. Wow. Never thought I'd see that. It's something else.
Yeah. So that's actually a video that we showed to our new hires and people who start working at Pros. So just talk a little bit about kind of where we've come from and what makes Pros special. Pros was not my first job right out of college. I worked for another company for about 6 months and ultimately moved to Pros. I interned for a different company, and I've had a handful of different jobs over my admittedly short career, but there really is something that I find really unique about Pros and special. And there's a lot of people who I think would agree with that. Actually, one of our managers right now and one of our tech leads are both people who used to work at Pros, left to go do other things with their career, and ultimately came back. And both of them talk about how important our culture is. And that's really why they come back. And so these three values, if we are owners, we are innovators, and we care, that really is kind of at the core of what Pros does, right? So ownership is huge to us, right? If you work for Pros, you're going to get great opportunities, but you're also going to be responsible for those opportunities and making sure that you make the most out of them, and making sure that you look at them from every angle, no matter what happens. Innovation is huge. We're on the cutting edge on our cloud technologies behind our algorithms. Our algorithms are written by scientists with PhDs across a number of different disciplines: machine learning, computer science, economics. We rely on their expertise to keep us on the cutting edge of that. And then we care is a really, really big part of what I do at Pros outside of my engineering job. I work with our ERGs, and so we have employee resource groups that support LGBT employees, women at Pros, Hispanic, Latinx employees, as well as African-American employees. Yes, that's all of them. And then also our Young Professionals organization, which I work with. And we try to take these opportunities to give back to our communities, to give back to the people that we recruit from and who support us, because that's really important to us. So that's really why I'm here today, is because we want to kind of invest in y'all as students. Whether or not you come work at Pros, like, we want you to know that our goal is to help grow you and your careers. And some of y'all will come and will benefit from that. But those of you who don't, we just hope that you can look back at something that a Pros employee did to help you get started. So, let me talk a little bit now about who I am, and then we'll get into the technical stuff. So my name is Chris Hawley. I'm 25. I graduated from the University of Houston in 2018, where I studied computer science, and I also have minors in mathematics and leadership studies. While I was at U of H, I worked with a couple different organizations, mostly within the Honors College. I did some programming with an organization called Data Analytics in Student Hands, and worked for Honors College IT. Like I said, I've been working with Pros since about 6 months after I graduated in December. And my main job, my day job, I work as a software engineer. I'm a software engineer too, and I work on what's called our cloud data platform. So cloud is a really big buzzword, and you're going to hear that a lot. And I would encourage you to pay a little bit of attention, because the cloud, as much as it is a buzzword, is really the future of what's happening in technology. And then this goes back to the innovation at Pros. I get to work on some really cool cutting edge stuff. Tomorrow, I'm meeting with a vendor that handles essentially like big data processing and really exciting stuff stuff that came out like 2 years ago, and we're already starting to get our hands on it. So it's very exciting. And then on the side, I get supported by my boss and by management to pursue things that I'm interested in, like these are kinds of recruiting and educational efforts. And I mentioned our ERGs. YoPros is our Young Professionals ERG, and I'm the president of that this year. So we really, again, we focus on developing you in every way that we can. We focus on a lot of kind of cross pollination of ideas between different segments of the business. And we even promote like cross hiring, in that if you're working in software engineering, but maybe you want to go work in professional services, that's something that you can do at Pros, which is not necessarily true of a lot of other companies, where they just want you to stay on the track that they hired you for, and they don't really care if your career develops. They just need you to get productivity out of you. And then I just put my favorite thing about Pros is the lack of hierarchy and the amount of agency I have in my career. I get asked the question, what do you want to work on, a lot, which is really exciting for me. I'm very passionate about technology and about what I do. And it's really exciting for me to be able to say this specific thing is what I'm interested in. I mentioned this vendor, and that was something that I asked to work on. I said, hey, I want to work I want to work with this Kafka stuff. I want to learn more about how this big data management and big data processing works. Can I work on that? And they were like, yeah, absolutely, hop on board, let's go. So that's what I really love about Pros. So before we hop into the technical stuff, anybody have any quick questions about Pros as a company or any of my background? Let me see, trying to pull up the chat.
There's no questions in the chat at this time, Chris.
Okay.
But of the students that are attending, they're all computer science.
Okay, awesome.
Yeah, so if you want to just kind of share a little bit, like what initially sparked your interest in like pursuing your major and your career path, I think that would be helpful too.
Yeah, I have a really weird career path. My senior year of high school, I was like dead set on being a music major, and I applied to the University of Houston and a number of other places with music education in mind. And I started at U of H. I did the whole auditioning process, and freshman year I marched in the marching band and everything. So that's what I really thought I wanted to do. And then as I was going through the process of starting music school, I just realized like, I like music, I really love music, and I enjoy being a musician, but this is not like what I want my career to be, right? The things that make you a good professional musician are not loving music. That is a requirement, but there's a bunch of other things, and I just didn't have those. So I switched, and I thought, what can I do differently instead of music? And when I was in high school, I listened to a lot of NPR because I'm weird like that. And I just remember hearing this interview with this guy who was like, programming is the future, like coding is the future. If you're doing anything in the future, you should learn how to code because it'll help you. And then he specifically was even like, musicians care about it. Like there's code that generates music and things like that. Just be interested in that. So I started to learn how to code when I was like 16. I had a little bit of that background. There's a website called Code Academy. And there's a million different ways to learn how to program at home. And so I just had started messing around with that stuff, and I thought it was really interesting. I looked into it. It's great career prospects, good salary and all that. And I said, I'd always enjoyed math as well. So I said, all right, I'll do this. And then as I was developing through the University of Houston, I really got interested in big data, and in particular in distributed systems. So in my mind, there's a lot of different technology going around, but we talk about data and data analytics. And that's a huge part of the world right now, is how do we extract value from this massive, massive amount of data that we have? And that's where all these algorithms come into play, and where people like our data scientists come into play. But if you have petabytes, millions, 500 million rows of something, you can't manage that the same way that you manage 1,000 rows or 10,000 rows. The bigger your data gets, the different your tools have to be to handle the size of that data. And so that's how I got involved in distributed systems. I was interested, like, how do you even have a petabyte of data? How do you store it? How do you get into different parts of it and read different parts of it? And so that's what I do now as a data engineer, right? I'm focused less on like algorithms that analyze data, but more preparing data for those algorithms. And so a lot of that I developed through going to things like this, right? And just hearing about what was going on in the industry, paying attention to stuff online, taking every opportunity I could to learn from people who are coming back to talk to us. And that's ultimately what landed me in this cloud data engineering space.
Thanks for sharing. We do have one question from a student from Ekram. He's asking, what would be a valuable thing about the industry you think you've learned after you graduated from UH Computer Science?
That's a good question. I was actually thinking about this earlier. The number one thing I had to learn is that your understanding is not universal. And that doesn't mean it's incorrect, right? Like the way that you understand the technology that you're working with may not be wrong, but there may be different ways to understand it, and that are both correct. And depending, once you start working with people who come from different backgrounds, who work across 20 years of education, in difference in education, or just even people who are, like I work with a guy who went to Berkeley, just the difference between what he was taught and what I was taught. You have to kind of figure out how to translate between all these different languages into these kind of core ideas. And that's something that I really encourage people to focus on, is like, don't worry about like the terminology and the definitions and like the syntax, like all of that stuff. You Google that, right? But the only way you can Google it is if like you know the idea, right? And the more you know those ideas, the more you'll be able to find answers to questions you have, and the more you'll be able to communicate with people that know these ideas in different ways than you. And we'll see a little bit of that in our presentation, right? I'm not going to show you like a bunch of like definitions that you'd write down if you were taking a test, right? Like I try to stay away from that. I want to talk to you more about like the abstract ideas behind it. Anything else?
Thank you. There's no other questions in the chat.
Okay, yeah, we'll go ahead, and there'll be a couple of other points to ask questions if you think of anything.
Perfect.
So REST APIs. If you haven't heard of a REST API at this point, we'll get there. They're very important, right? Almost everything that I work on is either a REST API or uses a REST API. They're just fundamental to the web, and the web is fundamental to the cloud. So we're going to ask this question, what is a REST API? But there's two parts to this word, right? Like, first of all, we need to know what an API is. API stands for Application Programming Interface, which is not any more helpful than the letters API. So let's kind of dig into what this is, right? So the most important word here is interface, right? And an interface is a point where two systems, they meet and interact with each other. If y'all, I can't remember, I know that the degree got shuffled around a little bit. If y'all learn in like kind of basic Java concepts or basic object-oriented programming concepts, you'll see this word interface, right? And you'll be told that in Java, an interface is like a set of functions without implementation, right? It's just telling you what you can do. So I asked a couple of different people that I work with and other people in the industry, what they thought of when they hear API and REST API, and these were some of their answers, right? An API is not always a concrete term. It's more about documenting endpoints rather than anything technical. That's really important, right? Like, we're not talking about something that has a real strong, rigid technical definition. The term API gets thrown around a lot. And means a lot of different things. Sometimes it's referring to like a specific application, and sometimes it's referring to like a set of applications or just an idea that applications share. But this idea about documenting endpoints, and we'll talk about endpoints in a second, that's really important. And it describes communication in an abstract way. This came from my architect, actually. He said, in the simplest terms, I would say that it's a way for two programs to communicate with each other. And the two programs could be running at different machines, written in different programming languages, et cetera, right? So it's independent of any language or any technology. It's just this idea of how do we define the way that you can interact with this object, this system. And what it really is, and this is a word that I would encourage you to think a lot about, is abstraction, right? And I took this as a very wordy definition from Wikipedia: the process of removing physical, spatial, or temporal details or attributes in the study of objects, systems to focus attention on details of greater importance. So let's abstract that a little bit and look at just the process of removing details to focus on details of greater importance, right? We don't need to worry about the physics of how a CPU works, right? I mean, you'll probably take a class and it's good to know at some point, but when I'm writing my code, I'm not sitting there thinking like, oh man, like what register is being used and what machine code command is being translated into what binary string and what series of voltages. All of that goes away. And I can just abstract and be like, this is a CPU. It processes things. And that's fine for me because I'm not worried about that. And that's what is really everything in computer science is about, right? Abstract out these lower level details so you can focus on exactly what you're going to do. So here's a great example, right? I think y'all start off in Python, so you should be familiar with this, but Python has lists, right? Or arrays in different languages. There's a number of different things, but we can go here and we can look at this documentation here about lists, and we can see all these different things that we can do with a list, right? So a list is our abstraction, and it gives us an API. We can append things. We can extend things, we can insert things, right? None of this has to do with like any of the details behind the scenes. It just gives me this abstract idea. I can add an item to the end of the list. And because I know how lists work and I know what appending is, I understand that. And it helps me do things that are bigger and more powerful than that. So this is an API, right? It tells me what I can do. And that's our first core idea. You know, what is an API? So now let's move on to the question of a REST API. So REST stands for representational state transfer, and it travels over the web using HTTP. Again, this is a stuffy definition. It's not really going to help us. What we have in a REST API is, again, a web-based application that has a collection of models and endpoints, things we can do things with and things we can do to them, nouns and verbs, right? Models are what you're working with, and your endpoints are what you can do. They're a combo of a path and what I call a verb, and we'll see what that means in detail in just a second. And then the last thing to know about this is it's a set of stateless requests and responses. So I'm going to send, you're going to have a client, and I'll show you a diagram in a second. It's going to send a request to the server, to the REST API, and then it's going to get a response back. And what I mean by they're stateless is that like each request is packaged and it's isolated and independent of itself, right? I can't send a request that refers to the last request I sent, right? That would be a state, right? That I have, I could send a request to get authentication information and then have a second request be like, see the previous request for my authentication. It doesn't work like that. You send a request and you get something back, and then it's over. And then I can take the thing I got back and I can put it in another request to say, hey, this is my token that says I got authenticated, but I can't relate multiple requests together. And so what this does is it gives us a really basic way, because there's no like big, massive state, different applications can all consume the same API. You can send a bunch of requests to the same API, and it doesn't matter how they get processed, if they're in order or whatever. It sort of does a little bit once you start creating resources and things like that, but it's not dependent on knowing anything about other requests. So it becomes a very powerful tool. So this is this diagram that I talked about, right? Where we have a client, a REST API, and then like, let's say a database in the background. So let's imagine like this front end is Twitter, right? And I log into Twitter, and like Twitter sends a message to the Twitter REST API that says like, hey, give me Chris's timeline. Like, what is Chris looking at right now? You're using these different words to say, oh, I'm doing these different things. And then you're going to get back data, usually in JSON format, sometimes in XML, but almost always nowadays in JSON format. And if you don't know anything about JSON format, just Google it later. It's just a way for us to describe data. It stands for JavaScript object notation. It lets us just take an object and write it down in a way. So, you know, like it'll give me a list of like, here are all the tweets, and one of the properties in the JSON object may be like the actual tweet itself and who sent the tweet, that kind of information. So this is the classic understanding of a REST API, and this is very common. But I would also encourage you to start thinking about REST APIs a little bit broader. And this is really more informed by the world of cloud computing and cloud development. In the cloud, we have what are called microservices. And so what happens is you've got like a web front end or maybe a mobile app, or maybe not even a UI at all, maybe just another system without a UI, and it calls my REST API. And that REST API may call a database, or it may call another service. We do this all the time. So for example, we have a service called Azure Data Factory, and we don't make it, it's Microsoft makes it. We pay Microsoft to use their service. We have a REST API that then sends another request to the Azure Data Factory REST API, and it sits in between that other API so that we can control it and do certain things to it the way that we want to. And we can abstract some of that out and hand it to other developers at pros. But I show this diagram because you're going to see a lot of stuff about just this guy going and communicating with databases and managing data and that kind of structure. But start to also think about the way that a REST API can be used to drive, functionality, right? To provision a resource, a virtual machine in the cloud or something like that. There's a lot of different ways you can do it. So we'll show you again another example. Here's a documented example of a REST API. This is the public Twitter API. So not the one that my desktop uses when I go to look at my tweets, or my phone uses when I go to look at my tweets. But if I wanted to write an application that like pulls my Twitter feed or something, I can do this, right? And so here's our model, right? A tweet or a user or a DM. And here's our verbs, the things that we can do to them, right? And so we can dig in here. And then we see what is really the definition of specifically the REST API. It's a post. I can take a post, which is a verb, and status / updates, and that will do something, right? And we'll get into how this all works once you see the actual examples. But you see how we have this, again, this concept of what are we doing, what are we working with, and what are we doing to it? Information about terminology. All of this is documenting this REST API. Here's our rate limits. It's all about information and understanding what we can do with a particular application or particular piece of code. So we're going to go into the demo now, and I'm going to show you how you can build one of these things really, really quickly. But before we go in, do we have any questions?
Students, feel free to either unmute yourself or place your questions in the chat about anything that Chris just shared before he jumps into the next section. All right, Chris, it looks like there's no questions at this time.
Okay, cool. All right, so we're going to go into the demo now. I'm going to stop sharing slides. I'm going to move over to the actual code, but I'll give y'all just a second. Write this down. Let me actually, oops. I can also send this in the chat. So that will take you to this page right here, which is the code. This is going to be the final product of the code and a little bit of what we're working with. Ultimately, I'll update this with a link to the actual demo, and I'll probably fill all this out a little bit more with some written instructions so y'all can follow along. But this is where we're going to end up. So you'll want to save that for later. But for now, and to really just show you how fast this is, I'm going to start just completely from scratch. I'm going to use what's called the MERN stack, except for I'm going to not use React. I'm just going to use Mongo and Express. Mongo is a database. Y'all probably have learned about SQL databases. Mongo is what is called a NoSQL database. We don't need to worry too much about it right now. It's just going to store information for us, and it's easier to work with to do something quickly than it is with to do something with like a REST API, or not REST API, a typical SQL database. Express is what's called a web server. it allows you to create an application that's listening to network traffic, and that you can send the requests that we're talking about to. And then we're going to use a technology called Open API. What Open API is what's called a specification. So you'll see this thing called a specification sometimes in the industry. And what it does is it means it's not code. Open API isn't code. It's instructions for how to write code. Let me open up the actual Open API specification, and I can kind of show you what I mean by that. If I look at this, this is the Open API specification. So it's going to tell me, okay, here are the versions, here are the data types that the Open API supports, right? And here's the information about it, blah, 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 how schemas are defined. All of this allows us to describe an API using a standard language, right? So this is a language for us to explain how an API works. And before we get into that, we need to get our our initial Express server working. So we're going to start with making a directory. I'm using Mac, which is based on Linux. If you're on Windows, it's going to look different. Don't worry. Some Googling will get you there. All right. And then I want to use npm, which is a node package manager init, and this will create a new project for me. So I'm going to, cancel this. Go into this directory I just made. All right, so we'll call it that, version 1. Just give it a little description. Index.js is fine. Test command we don't need. Don't worry about Git repository. All this doesn't matter. Put your name in. This only matters if you're going to actually publish this somewhere, which we're not, so does not matter. Sounds good. All right, and then I'm going to open this in Visual Studio Code. If you have not seen Visual Studio Code, I highly recommend it. You may have worked with Visual Studio in the past. I'm not a big fan of Visual Studio unless you're using something like C# or F#, which specifically are Microsoft. But for the most part, I don't really like Visual Studio. Visual Studio Code, on the other hand, is amazing. I use it for all the different languages that we use. My team manages like applications in, I don't know, 5 or 6 different languages, and I just do all my editing in this. It's just a text editor with a bunch of really, really good plugins. So what we've done here is we've created this package.json, which explains all the different dependencies that we need. I'm going to go ahead and skip this step and then just copy the package.json from our final copy so that we don't have to go through it. But let me explain all the different parts. These scripts are automated. Whoops, that's not what I wanted. These scripts are automated commands that you can execute. So start will run this script, will run this index.js file, more information, and then these dependencies. Now, this is, again, going back to this API idea, all of these are libraries, right? Express, like I said, creates a web server for us to use. They all have APIs that we can access, and they define them for us. So we're going to import all these different ones. Express is used for the web server. Express Open API Validator validates our requests with the Express server. Mongoose allows us to connect to a Mongo database. NodeMon is for development. Path is an internal tool that tells us where we are. Swagger UI will give us documentation, and then UUID and YAML.js are other utilities that we need later. So now what we're going to do is we're going to create a directory source. But whoops, not a file. We're going to create a source directory. And then inside of that, we're going to make a file. We're going to call it index.js. And then what I'm going to copy here is just the hello world explanation from, oh, whoops. hello world right here. So we're going to make a basic web server that does this. And we're going to go ahead and add one more thing here. So we'll add a second endpoint. So remember earlier we were talking about endpoints and verbs. I've created two right now. One is this path slash, and the other one's test. And we're listening on localhost and a port. If none of that stuff makes sense to you, don't worry. A port's just the way for us to, we have to define a specific port we're listening on for the web. It's a security thing, among other things. But what will happen is this URL, localhost at port 3000, will give us our application. So we should be able to hit npm start at this point. Oh, I need to do npm I. This will install my dependencies. So right now I'm pulling down all the different applications, or not applications, but libraries that I defined in my package.json right here, these guys. And you see this node modules directory. This is all the code I need to run it. We don't need to worry about that now. We just know that it's there. And once this is done, we can run npm start. And then boom. So we're listening now on localhost 30 or 3000. So now I can use curl, which just sends an HTTP request. Right? And it says hello world. Like I get this hello world response back. Or if I say test, I get testing. So there are other verbs, and we'll talk about those just a second, but now we have ourselves a REST API, right? But notice that in order to do this, I have to write each one of these specific paths. And if I wanted to come and use this REST API, I wouldn't have any way, I wouldn't have nice documentation like with that Twitter one that we were looking at. So there's a lot of steps missing, and that's what OpenAPI is going to do it for us. So the best way to get started with OpenAPI is to use this API Curio tool. There's a free version with a link to it in the GitHub, so you can find that later. But this tool right here will allow us to create what's called an OpenAPI spec. So I can go in here and I can hit create new API. Right? And then I'll just make it blank. I hit create API, and now I can edit this. I'm not even having to write code right now. I can just define what we need. So remember I said I got to define models. So what we're going to do today is we're going to make a bookstore, right? So let's say this model is called book. Its description is a represent. Right? And then we'll get a JSON example down here. We don't need to add that right now. Let me steal my JSON example for my other API. This is a spoiler, don't look. Okay. So I go in here and add this. So we'll have an ID, because all good systems have unique IDs. We'll have a title, an author, and a genre. So I'm going to add this. I made a slight mistake. I need to delete, create. All right, so I'm going to add this here. And then when I come down here, I can choose REST resource, and it'll create a couple of endpoints for us. So I click save, right? And now we've got this data, right? This object, this model, and we've got all these different paths. And then these are the verbs that I keep talking about. HTTP has specific verbs that have certain semantics to them that we're supposed to follow that do certain things. So for example, get is how you retrieve something. You don't have to, you don't use it to create anything new or modify anything. A GET request should always just return data, not change anything. A post is used to create a book, right? So if I go here and if I did curl-x post, it will send a post request instead of a get request, right? A put is usually used for updates. So what we've done here is we've created what's called CRUD operations, C-R-U-D, create, read, update, delete. This is the kind of fundamental idea you learn about all over the place. Whether you're designing like a class in Java, you need to have ways to read and update and create these class, or it's really big in these REST APIs. I need a way to create a book. This gets a list of all the books. I need to be able to put a book, meaning update the book that exists, delete a book, or retrieve an individual book. But let's say we wanted to add a custom path, right? Let's say we want to get books by genre. Okay, so we can now add another path, and I can hit get. We need to make sure this path we add this path parameter, meaning what a path parameter is it's a parameter or an argument that's in the path. So when I go to do this, I'm going to put a string here, and it's going to be inserted into this parameter. We'll see that in a second. And then I can hit add operation to add my get operation. And then I can define this here. So again, I'm going to take a shortcut and go ahead and just copy the one I have that I know is working so I don't make any mistakes. But I can go in here and I can save this. And now I have these different, all these different endpoints and this model that I originally created. So we can go in here, we can see I added this get, I'm slightly different. I don't have the query parameter or path parameter here. I have what's called a query parameter down here. I supply genre. We'll see how we do that once we start playing around with this. So I have now this API that's designed, and I have this document right here that describes this entire API. And I generated this without having to write any of this code. This is a code format called YAML. It's basically just JSON that's easier to read and write. We can look at it in JSON as well. This is what JavaScript object notation looks like. But we have this document, and what this document is our API explanation. It will be used to generate our UI. It can even be used to generate code, whether it's code that calls this API, what we call client code, or server code that will implement this API and handle it, which is what we're about to write. And it's language independent. So I can start to write this in JavaScript today and then realize we need to move this over to Java for whatever reason. You know, there's a particular library that you need or a technology you want to use that doesn't support JavaScript. Before, I'd have to like translate this whole thing over. Now I've got this API right here. Okay, everything's all in one place, and it does not matter. And I can use all the technologies that can use this specification to do things. So let's get back to this actual code. What we need to now do is add a route. So we'll go ahead and under source, we'll make a new route. We'll call, or a new directory, we'll call it routes. Inside of it, we're going to make our books.js. This is going to be our route. Our set of routes, I guess. And we're going to, this is our code. This is all we need to implement everything, except for we need to add some database models, which we'll do in just a second. There is one thing, I need to go here. I need to add the open API directory, and inside of it, I need to add, right? And then I'll paste, not that one. I'll paste my YAML file here. And then the last thing we need to do is in our source directory, we're going to go ahead and wrong directory. We're going to make our DB folder where we'll store our mongoose information. And then we're going to create a new file called book model.js. And then again, I just have all this written. This is going to be the model that we use to write to our database, read and write to our database. So I have, again, Mongoose here. I define a book. It has an ID, title, author, genre. You can define the types of everything, give it default values, and then we export that. And then here we import our book model, and we use that book model to create, update, read, and delete these books. So if we look here, we've got get all books, where we're going to just do book.find. That query will give us, it's sort of like select star, where, you know, it's just select star, give me everything in this table. In Mongo, they're called collections, not tables, but give me all the documents in the book collection. Get book by ID, we'll do find where ID is the book ID. And the book ID we're taking from our request. These right here is our request object, response object. They're given to us by Express. And then I can take the book ID provided and I can send it off, or I find just this one book. Or by genre, right? Provide a genre, I can just find book by genre again, and then create book. We're just going to create one, update book. We're going to find one, or update and then return it, and then delete book. We'll return it again. Now, you're probably wondering how we get from the paths we defined to this code. And we do that by using these extensions. So when you see this X, that's not a part of the Open API specification. It's something that is added by the library, which we call Express Open API Validator, that we use, is then used specifically by this library. So if you do this in a different language like Java, you may not have this exact same thing. You may have to use the operation ID. You'll need to read the documentation of whatever library is you're using to consume your spec to know how you route it there. But for this JSON or this JavaScript example, we tell them where the handler is. So here is the file name, right? It's in routes./books. And then we get book ID, get book by ID is the name of the function we're going to call, right? And now we have all of this. We don't need anything else. That's all you needed to get this running, right? And yeah, I copied a few things to make sure I could get this all done in 30 minutes, but it's not a lot of code, as you can see, 65 lines here. Oh, we need to update our index.js. I forgot this one step. 40 lines here, 27 lines here, and then this is auto-generated for us in under 200 lines. So we're at like 500 lines of code, most of which was auto-generated, and we have a fully functioning API. So let me walk you through what we just added here. Again, we added all these different imports. These are the different utilities that we need. Right here is we're going to connect Mongoose to our local MongoDB instance. On here on my second monitor, I've got MongoDB running locally. You can do that. You can run it as what's called a Docker container, or you could use a cloud service like Cosmos DB is the Azure one. I can't remember the name of Amazon, but Amazon has like a free, not free, but has a software as a service cloud version of MongoDB that you can connect to. And then you would just update this connection information to check to connect. So I'm going to make this right here. I'm just changing the database name that we're using. On /docs, I'm going to do what's called serve the Swagger UI. This takes our Swagger document, which you can see is up here, our bookstore.yaml, and it creates a documentation from that. Body parser, this is just used to pull body data and make it more accessible. And then right here is this EOV thing that we keep talking about. There's this stuff called middleware and Express. Don't worry too much about it. We're just registering Express and Open API Validator with our web server Express so that it knows, hey, use this library when you get requests instead of processing it like normal. And then this is our error handler. And then again, we tell it to listen. So now what we can do, I can open up this and I'll run it again. Oh, it's running on this. Okay, we have an error. This is the life of a software engineer. So I need to, this it? Let's see if my old demo works. Okay, we have the other version running. I must have missed a step somewhere, but it's the same thing. You can see we've got Open API, our bookstore model, our index.js. So now we're ready to go. And I can go to my web browser and go HTTP localhost 1000/docs, because remember we said the path/docs will do this, and boom. Now we've got this nice fancy documentation that has all the information that we just put into our API spec. So what Open API and this idea of rapid API development is all about, if we center around this language agnostic spec, we can do a bunch of different stuff with it. We can use it for routing, right? To tell the application where to send requests when they go to certain endpoints. We can use it for providing documentation so that people can access it. We can use it for code generation, like I said. We have this centralized description of our application program interface, and then we can handle it everywhere. And in fact, you can use Open API to describe interfaces that aren't even REST APIs. We have these paths, but some people, we use our Open API to then generate sometimes like library code or software development kit code. So you could do a bunch of different things with this description. And for anyone who's worked with something that doesn't have this, getting from nothing to this point right now, this is fully functioning. We will use it here in a second. In this time that we did is much, much faster than if you do something like this. Whoops. Let me show you an old project that I worked on when I was a student and how much more frustrating it was. So this is a Java backend. Whoops, not doc. But you have to go, and I have these POJOs here I have to define, and then I've got these resources, and I have to go in here and I have to annotate different things, say here's our post and here's this, it returns a response, and see how much more messy this is and how much more effort it is to get all this up. And then you can take these annotations and serve a Swagger UI, but I had to write all this code. I couldn't generate any of this code. I couldn't generate, I couldn't generate this documentation with a UI like I just did with API Curio. All of this was an extensive process, and it's just uglier and much more messy to play with compared to this. Like, this is clean. This is initialize our server. Here's what we're doing. Now, JavaScript in general has a lot of things that I'll be the first to complain about. So this is less of me advocating specifically for this JavaScript. JavaScript is really good. I recommend that you learn a little bit about it and understand where it's useful and where it's not. But again, you could do this in Java or Python or Ruby. It doesn't matter. It's going to be equally as elegant and easy to get running. So now, before we go into the question stage, let's actually play with our UI. So I have right here some data. So let's send. Let me show you one other thing that you can do with this. Another thing you can generate. This is called Postman. It's just an application that lets me send HTTP requests. It's doing the same thing that curl was doing, but I have a lot more help here. I can go to import right here and import my API spec. And now I have all of these requests auto-generated for me. So I can use this UI to play with it, or I can use Postman, right? So let's try this. Let's try and create a book. Okay, so we can go to body, see it gives us a sample one. We'll paste this. I'm going to call in, this is a book I'm reading right now, Pillars of the Earth by Ken Follett, historical fiction. I send that. Boom. All right, it tells us this is the application. This is what we need. Don't worry about _v and _id. Those are from Mongo. That you can trim them off if you want, but here's the information. I have a title, author, genre, and it auto-generated my ID for me, right? So now I can go and do it again. Send that. And I've got Ender's Game right now. And let's just go ahead and add a couple of other ones. So we have a few more things to play with here. Here's Starship Troopers, another sci-fi book. Here's a nonfiction book I like, Outliers by Malcolm Gladwell. All of these are books I highly recommend for real, by the way. And then Tipping Point, we'll go ahead and send this. But if you realize, if you know what Tipping Point is, or if you know who Malcolm Gladwell is, you know that this isn't a fiction book. This is nonfiction. I just messed up, right? So now I need to go in here and I need to update it using my update endpoint. So I can now say nonfiction. Send that. All right, and we get nothing back because it was, we see 200. This is the response that I keep talking about. It says 200, that's okay. It tells me how long it was, how big the size is. There's nothing in here. And then I can now go here, I can list all my books. And I can see that, whoops, must have messed something up. Well, I have a bug. I'll find that later. Ideally, this would update and we would see this here. I'm not 100% sure why. Let's see if we have an error. Nope. Looks like it's working. I just have a bug in my code, apparently. Oh, I know why. I don't have a bug in my code. I'm making a mistake. I have to specify this book ID right here. So what's going to happen is it's going to inject this. I could do it like this. Here's my path. Base URL is localhost. That's what that path parameter is going to do, right? So now I send this body. What? Oh, I didn't give it. There you go. Now it's updated. I can list all my books and see it down here. And then finally, we can delete the same thing. So let's say let's say I sold Tipping Point. I don't want it anymore. I can go in here, add this, delete it. And then now if I list all my books, you see that Tipping Point is gone. You just have Outliers. And then finally, we have this query parameter. You see this question mark, and then it says genre equals whatever. Let's make the genre equal. We can pass named parameters like this as this query parameter. So there's different ways you can pass it in the body. You can pass it in the path or as a query parameter. Send that. Oh, did I misspell sci-fi? There you go. It's capital. So now I get my sci-fi book. And that's it. That's the whole thing. We're ready to go. If I wanted to, I could very easily come in here, go to API Curio, add a new object, add more paths, expand this. Maybe I start carrying magazines. I can go in here, create a magazine, REST API, boom. Now I've got a magazine, create, read it, update endpoints. And I can just set up a new route in here. You know, maybe, let's say, and then, you know, it's going to be very similar to books. So we'll copy this and modify this. And now I just extended my API. And in my clients, my UI will be updated with it, everything. It's all synchronized. So that was 30 minutes roughly from nothing to functional API. And you can use these in your classes. Like I think when I was a student, if they're still doing what they used to, like in the database class, you have to like build a whole system with a UI and everything. Well, you're going to want a REST API. I mean, we just did that, right? Like here, you could build your database structure here. And if you can't use Mongo in that class, well, you could still, Mongo isn't necessary for using OpenAPI. I can attach to a regular SQL interface if I want to. I can take these different components and slot in whatever I need for the particular project. So that's how that works. I'm happy to go over any questions you guys have about any of the stuff we just covered, APIs, REST APIs, and OpenAPI. I know that's a lot of information. Hopefully it'll get you kind of an idea of what's going on. The best way to learn about this stuff is just to go out and play with it. I'm also happy to answer any questions about the industry or my background or anything else y'all may have.
Thank you so much, Chris. I don't see any questions in the chat right now, but students, as Chris shared, please share any questions that you have in the chat, or feel free to unmute yourself. He just went through a nice demo and step-by-step with you all, but he also is a UH alum and has an industry experience that he can share with you too. Chris, are you okay with sharing your contact information with the students that attended the session?
Yeah, absolutely. I mean, the best way for students to contact me is going to be LinkedIn. You can just search my name.
Perfect.
Yeah, if I get external emails, a lot of times they get like filtered into some quarantine thing, and I can never find them. So the best way, if you want to contact me, just search Chris Hawley on LinkedIn, and usually pop up pretty high. Let me show you.